All right, let's take a minute and look at some examples of a random variable versus the distribution. So the random variable here is the number of times that you get a 4 in 6 rolls of a dice. Now, notice here, this is saying how many 4s you get in 6 rolls of a dice. This does not deal with probabilities. We're just discussing the possibilities. So the random variable is just saying when you roll a dice, 6 times, how many times are you going to get a 4? And we're just saying I can get 0, 1, 2, 3, 4, 5, or 6 4s whenever I roll the dice, okay? So you want to be careful with the difference between the random variable. Now let's take a look at the distribution. The distribution deals with the probability of getting a 0, 1, 2, 3, 4, 5, or 6 4s whenever you roll a dice. This is more like the tables that we talked about in section 5.1. We made the tables and then gave the probabilities. So in this case, n is equal to 6. My probability is 1/6. And you have a 1/6 chance every time you roll a dice, and you're going to get a 4. This is the distribution, N and P. 6 trials, probability of success, or getting a 4 is 1 out of 6. The random variable is just defining what you're doing. It's not talking about the probabilities. All right, so let's take a minute and see if this is a binomial setting. Dice, cars, and hoops. Determine whether or not the random variable below is a binomial distribution. Justify your answer using bin. So notice we have the word binomial distribution. That means you're going to take a look at n comma p. So you have to know how many trials and what is the probability. If one condition is not satisfied, then it's not binomial. And make sure your answers are always in context. So in AP Statistics, it has to be in context of the problem. So go ahead and take a minute and read these. We're rolling a dice 10 times, and X is the number of 6s. B is shooting a basketball 20 times from various distances on the court. Y is the number of shots made. Now notice this is the random variable defined. It's not the distribution because I'm just defining it. And C is observe the next 100 cars that go by and let C equal to color. Try these on your own and then take a second, pause the video, and check your answer on the next few slides. All right, so take a look at this first one. When we roll a dice 10 times, X was the number of 6s. Yes, this is binary. It's either success or failure, 6 or not a 6. It's independent. Each roll does not affect each other. There are 10 trials. There's a fixed number of trials, and the probability of success each time is 1/6. So this is a binomial setting with n is equal to 10 and probability of 1/6. So we could say this is a binomial distribution of n equal 10 and p equal 1/6. And notice these are all in context. It doesn't just say like, yes, success or failure, independent, yes. We're talking specifically about the rolls of the dice. All right, now let's go ahead and take a look at letter B. So B was shooting a basketball 20 times from various distances. Y, our random variable, was the number of shots made. Was it binary? Yes, you're either going to make the shot or not. Notice that's in context. Independent, yes, evidence suggests that it's reasonable to assume that knowing the outcome of one shot tells us nothing about the outcome of the other shot. So one shot does not affect the other. The number of trials, yes, there are exactly 20 trials, but the probability of success is different because the shots change as you move from various distances around the court. So this is a random variable, the number of shots made. It's just not a binomial random variable because the probability of successes are not the same each time. Now, how about letter C? So we're observing the next 100 cars that go by, and C is equal to color. Is this binary? Well, no. There's more than 2 possible colors, so we can't say color yes or color no. So right then and there, we could say this is not a binomial setting, and you don't actually need to do the rest of them. It is independent, okay, because knowing one color does not tell you anything about the other colors. There are exactly 100 trials, so there is a fixed number of trials, and our success isn't defined. C is equal to color, so we're not talking about the number of colored cars that we see and what is the color, green, yellow, purple. That hasn't been defined, so the probability of success can't be the same. So since there are more than 2 possible outcomes for the color of the car, it's not a binomial random variable.